First, let me explain what is a piecewise function. Well, it's a function that has other functions in it in pieces. So notice this example here. This piecewise function has two different functions, and I'm only taking pieces of those functions. I have my first function x squared, which is my quadratic, and I'm only concerned about the quadratic in values that are less than 0. So the first thing we're going to do with piecewise functions is learn how to graph them, and then we'll learn how to evaluate. So x squared, quadratic, what does that look like?
X squared quadratic?
Yeah, if you could call it a letter in the alphabet, quadratic would be the letter.
I'm thinking 1, 2, 3.
No, letter.
Oh, letter.
Yep.
X.
No,
Y.
no.
Well, wait, say it again.
You don't remember what a quadratic looks like? X squared?
I.
Well, if you ever want to know what these piecewise functions look like, then you should probably grab your calculator and graph it. So x squared looks like a U.
Oh.
So let me sketch
Oh, no, but it did.
my quadratic
Oh, what the?
here.
Oh, bruh. Somebody put this in the calculator.
Now, we'll get there. So now here is my full quadratic, but I only want the part that is less than 0. So which should I erase, the left side or the right side?
Less than 0?
Yeah, I want values that are less than 0. So what should I erase?
The right side.
The right side, right? All these values that are greater than 0. Now what do I do for 0? Well, in the terms of this inequality, I'm going to put an open circle. If we can remember some notation, if my inequality is less than or greater than, I want an open circle. As far as interval notation, it's going to have parentheses. Where less than equal to or greater than equal to is going to have a closed circle, and interval notation is going to be brackets. So that's why I'm going to have an open circle here, because I don't have that equal sign. So here's half of my piecewise function, half of my quadratic. Now let's look at my square root. I want to graph that square root function, and the square root function looks like that, where I want to account for all values of x that are greater than and equal to 0. So equal to, I'm going to put a closed circle, and then actually, as it turns out, the rest of my graph is in fact greater than 0. So here is my complete graph of my piecewise function. Notice it's in two parts. The part that is less than 0, which is my quadratic, and the part that is equal to or greater than 0, which is my square root. So that's what we're doing today. Two functions in one, just cut into pieces. So let me have you give it a try on your graph paper. Graph this piecewise function. The first one, these are linear, so you should know how to graph it, is x minus 2. What is my y-intercept?
Oh, we didn't know right here.
So this is already set in slope-intercept form. What is my y-intercept? What's the y-intercept?
Y-intercept of what?
Of my function here, x minus 2. If you were to graph this, you need to graph the y-intercept, which is
0. -2.
0, -2. That would be your point. And my slope is
X1.
1. While this function, it has a y-intercept of 0, 5 with a slope of -1. Now when you graph this one, only graph values of x that are less than 3, and this one, all value of the graph that is greater than or equal to 3. So I'll give you the amount of time it takes me to do. So let me look at this function. Again, I have a y-intercept of 0, -2, and a slope of 1. So roughly my graph is looking like this, more or less. And I want to grab all values in terms of x that are less than 3. So at the point 3, am I going to have an open or closed circle? Open. And I want to erase all values left or right?
Right.
Yeah, to the right. I don't want anything greater than 3. I want it all less than 3. So there's the first one. Second one, here I have x-intercepted, a y-intercepted 0, 5, and a slope of negative 1. Something like that, more or less. And at 3, I am equal to that point, so I want to have a closed circle, and I want to erase everything on the left or right of it. I want to keep all values greater than 3,
Left.
so I want to erase the left side, like so. So here's kind of a sketch of what your graph should have looked like. Now there is some good news. As it turns out, it is possible for our graphing calculator to graph piecewise functions.
Go back.
But you need to pay very close attention because it takes precise syntax. Now, first thing is to note that my piecewise function is divided into 2 parts, the function and the inequality. I'm using the word divided here for a purpose. Because when you want to graph it, first you graph the function just like you see it, so x minus 2. So you may want to follow along, and those online, you should have the TI calculator app on your computer. If not, there is something in a resource folder on this class on how to download it. And like I said, it is divided between the 2. So you need to take the function and divide by the inequality. So make sure you use parentheses here with the inequality. So function divide, open parentheses. X, in my inequalities, x is less than 3. Well, where do you find less than 3 in the calculator? That is right here by math in the test option. Oops. Delete that. So second math gives me here. There's your inequalities. I'm looking for less than 3, close parentheses. So note the difference between what it looks like in the calculator and the actual notation of piecewise functions.
So you have to put the comma too or no?
No, instead of the comma, we are going to use divided.
Okay.
Divided.
Wait a minute.
So for the next one, 5 minus x,
Okay.
instead of instead of the comma, I want to divide by the inequality. So open parentheses, x is greater than or equal to, so second math, greater than or equal to 3, close parentheses, and graph. Hey, is that not what we got? Pretty close. Oh,
Wait,
came really close to using the same colors.
wait, go back.
Hey, where?
Why the colors like that?
I have colors you don't.
Oh.
Yeah.
How about? Okay.
Now note,
Huh?
there are not open and closed circles here. The calculator doesn't do that. So that you'll have to do on your own when you want to sketch it. All right. Notice with this example, how many functions are in this piecewise function? 1, 2, 3. Now, this one has something we haven't seen so far, a compound inequality. The calculator will not recognize a compound inequality if you put it in like this. So you have to separate it. Notice a compound inequality is just a lazy man's way of writing 2 inequalities in one. So this is actually x is greater than and equal to negative 3. And at the same time, I also have x is less than or equal to 5. So if you're going to plug in the calculator, it's got to look like this rather than this. And I'll show you how to plug that in. So let's plug in this piecewise function in the calculator and look at the graph. So I have the first one, absolute value of x. Well, where do you find absolute value? 2 clicks, 2 options. Math, go over to number, ABS. That's your absolute value. Or you could do alpha window, and your first option is ABS. So 2 ways to get to absolute value. So I'm looking for the absolute value of x with the conditions of x is less than negative 3. So what do I put here? Divided by x, second math, less than negative 3. So there's the first one. Notice the second one is just a function y equals 3. So you're just going to put 3 divided by let me look at my first inequality with this set. X is greater than or equal to negative 3. So x is greater than or equal to negative 3. And here's where you have two options. You can either close this out and then start a new 3 divided by the other one, or you can put them together like so. Second math, here's my inequalities. If I go over one, I get logic, which I have the words and. Click on and. So with this function, x is greater than or equal to negative 3 and x is less than or equal to 5. So x less than or equal to 5. Here's how you would write a compound inequality in the calculator for it to understand. And then the next is 2x minus 7 divided by x is greater than 5. X is greater than 5. So here's how you would correctly put in that piecewise function in the calculator. And hit graph. There it is. There's 3 functions graphed given their conditions as a piecewise function. Again, note it's missing the open circle and closed circle. That you have to do on your own. But this is a good start, especially if you want a quicker way to graph instead of having slope. Sometimes if they get more involved, like let's say this quadratic had a compression, that's a little bit harder to sketch by hand. So that is graphing. Calculator is a big help there. One of the biggest things to do with piecewise functions is evaluate it. So here's that same piecewise function. Now I want to find where f is negative 5. And f is negative 1 and 0. The biggest mistakes I see with these is, one, you're not paying attention to what I'm saying right now, because you have no idea how to solve it and how to go from here. We are used to reading from left to right. So when I see a student that doesn't know how to evaluate a piecewise function correctly, I see them look at this negative 5, and then, well, they're going to do what they know how to do, and that's plug in that for x. So they're going to plug in that to each of those functions, and then I guess they determine if that value satisfies this condition. Well, that's backwards. That's not the correct order. If I was master of the mathematical universe and in charge of piecewise functions, I would change this, the inequality, I would actually move it out in front, because this should be what you look at first. You should look at the inequalities first. So when I'm looking at f of negative 5, I need to ask myself this question. Where does negative 5 fit within this inequality? Is it less than negative 3? Is it between negative 3 and 5? Or is it greater than 5? Where does it fit? Which of these inequalities satisfies negative 5? Sesame Street, Season 1, Episodes 12, inequalities. Is negative 5 greater than 5?
That inequality is in Sesame Street?
Is negative 5 greater than negative 3 and less than 5? Or is negative 5 less than negative 3?
I can say no.
Okay, so negative 5 works for this one. Negative 5 is less than negative 3. Which means the second thing I need to look at is then the functions. Once I determine that it works here, negative 5 is less than negative 3, I only want to concern myself with that function associated with that. So I only want to look at the absolute value of x. So f of negative 5 is less than 3. Check. Now, I need to find f of negative 5, which equals the absolute value of x, which equals the absolute value of negative 5, which is what? Absolute value of negative 5 is 5, yeah. Turns everything positive. So that is 5. So the answer is 5. First, you look at the inequality, and that tells you which function to focus on. So looking at B, which inequality should I focus on?
Second one.
Second one, right? -1 is in between -3 and 5. What is the function for -1? What function does that concern me with? 3, which means the answer is 3. There ain't nothing to plug in for x, it just tells you when you get to this function, the solution is 3. What about C?
The second one.
Second one, therefore the solution is 3. Yep.
Mr. Clark, how do you know which one is a different color? Like, can they both be red?
For white.
Can they both be red?
I don't know.
What do you mean?
What are we talking about?
Colors are not needed.
What is it called? We got piecewise functions practice. Can they like when you're answering them, I have them both as red. Can I just change the color?
Oh, it does. No, you don't have to change color. It's all going to be one function, so it can be the same color. Yeah, you're doing that assignment. I'll go over that assignment in a minute. So now I want you to take a minute or two and evaluate this piecewise function. Find f of -5, f of -1, and 0. All right. So tell me, what is A? Where does -5 fit?
First one.
First one, right? So I'm looking at f of -5 equals 2x, therefore 2 times -5, therefore -10. Should have got -10. Worked right here. -5 is less than or equal to 1. Next, f of -1, which one does it work for? -1, is that less than or equal to 1 or greater than 1?
First one.
First one, so therefore it equals -2 times -1 is, sorry, 2 times -1 is -2. And f of 0,
First one.
first one. 2 times 0 is 0. Now, I will mention this. The calculator, if we plug it in correctly into y equals, and we hit graph, it helps us graph the piecewise function. Can it help us evaluate?
No. Oh yeah,
How?
sort of.
What? How can the calculator help us evaluate piecewise functions? If hidden graph helps us graph, looking at what helps us evaluate? Table, very nice. If I go to second table, what do you see? So I'm looking at this one here. So hold on. I'm looking at this one here. I want to find f of -5. So let me go at my x value of -5, and what does it tell me that it equals?
5.
5. If I want to look at -1 and 0, what does it tell me -1 and 0 equals? 3. Now what are these error messages?
Non-existent.
Non-existent. What does that mean in terms of this graph? This blue line, it really continues, right, with the function? And where I told it to stop based on that condition, that's where you're going to get your error messages. So you can actually ignore these errors. They just tell you where your function, where the one function stops and another begins. So notice this function stops here with error, so that function right there stops. Then this one starts all the way down. So with this piecewise function, can somebody tell me what is f of 13?
19.
Yeah, 19. So pretty nice. If you can enter it correctly, again, you're relying on being able to put in this the right way, then you can get the graph, and it can really help you evaluate by looking at the table.